Classification is used if the target variable is categorical, such as female or male. In this video, I am gonna talk about classification using PyCaret. PyCaret is a simple, easy to learn, low-code machine learning library in Python. Using PyCaret, you can automate machine learning workflows. To show this, let me load diabetes dataset. First, I am gonna import pandas. Import pandas SPD. Okay, let's load the dataset using read CSV method in pandas. Data equals pd.read CSV. Let me set the name of the dataset. Diabetes.csv. Cool. Let's take a look at 5 rows of the dataset using heat method. Data.heat. Here target column is class variable and the other columns are feature variables. Beautiful. So far we loaded the dataset. In the classification analysis, the goal is to predict the categorical class labels. To the classification analysis, you can use PyCaret classification module. Let's import this module from PyCaret.classification import. To import all function, let me set asterisk. Okay, now I am gonna use the setup method to initialize the analysis. This function creates the transformation pipeline. S equals setup. Setup function takes the mandatory parameters. These are data and target. Let me set these parameters. Data, comma, for target parameter. Let me set the name of the target. Class variable. PyCaret will automatically find the data types of all columns. As you can see, data types were inferred by Caret. Make sure that data types are correct. This is important to build a machine learning model. If data types are correct, you can press enter to continue. Let me press enter. You can see all preprocessing and transformation in this table. For example, session ID is 7016. This controls the randomness of experiment. Target variable is class variable. Target types is binary. Label encoded is none. The structure of original is here. No missing data in the dataset. Here, you can see the other values. Don't forget, I configure all the preprocessing and data transformations within the setup function. Cool! Our dataset is ready to build the model. To build the model, I'm gonna use the compare models method. This method trains and evaluates the performance of all estimators using cross-validation. To build the model, let me set best compare models. When I run this command, the estimators is training and evaluating. Estimators are trained and metric values are returned. You can see the metrics of estimators. The yellow areas show the algorithm's best metrics. By default, the best estimator was specified by the accuracy metric. You can use the sort parameter to find the best model based on a different metric. You can change the sort order by passing the name of the metric based on which you want to the model selection. According to accuracy metric, logistic regression has the best accuracy score. Cool! We saw the performance of the estimators. Let's print the hyperparameters of the best estimator. To do this, let me set print best. Here you go. You can see the hyperparameters. Let's take a look at the performance of a trained model on the test set. To do this, I'm gonna use evaluate model function. Evaluate model best. You can see the performance of the best model. For example, there are hyperparameters. If you press out bottom, you can see the log curves. Or if you want to do precision recall graph, simply press precision recall bottom. To see the feature importance plot, I'm gonna press feature importance. Cool! Don't forget evaluate model can only be used in notebook. You can also use the plot model function to generate individually. For example, let's take a look at our curves. Plot model best, comma, plot awk. Here you go. You can see the confusion matrix. To show this, plot model best, comma, plot equals confusion underscore matrix. Here you go. Okay. We built our model and saw the performance of the model. Now let's take a look at the prediction of the model. To do this, I'm gonna use predict model function. This function predicts the label and score columns. Predict model. Let me set best. Let me run this comment. Cool. Here you can see the metrics of the model. The evaluation metrics are calculated on the test set. Our model has 0.77 accuracy score. You can see the second output which shows label and score columns. Let me zoom out. Note that score column refers to probability of the predicted class. When the data parameter is none, the model predicts label and score on the test set. Let's look at the first row. Our model has correctly predicted the first sample. Class label is 1 and the prediction of the model is 1. You can see the other predictions. To prediction the new dataset, you can use data parameter. To show this, I'm gonna simply pass the dataset. Let me zoom in. Okay. Prediction equals predict model. Let me set the name of the model. Best. I'm gonna pass data for data parameter. Data equals data. To see 5 rows, prediction dot heat. Here you go. You can see the prediction of the class label in the data frame. Cool. So far, I showed you how to build the model and predict a trained model. Now, let's take a look at how to save the model. To save the model, you can use the save model function. Let me show this. Save model. First, I'm gonna pass the model of our model. Let me set best. And then, I'm gonna set a name. Let's say, my best pipeline. Cool. I saved the model in my working directory. To load the model back in the working directory, loaded model equals load model. Let me set my best pipeline. Let's print the loaded model. Print loaded model. You can see the pipeline for our model. Beautiful. I talk about classification using PyCaret. In short, I showed you how to preprocess the data, build and evaluate the model, predict the new data, save and load the model. In the next video, I'll show you how to do a regression analysis using PyCaret. That's it. Thank you for watching. You can find the link of this notebook in the description below. Please don't forget to subscribe to my channel, press the bell icon, like the video and leave a comment. See you in the next video. Bye for now.